Good morning, my dear students. In this today's lecture, we will mainly concentrate on logic families. In the previous lecture, we have discussed in all the previous lectures. We have discussed the first chapter, that is basics of digital electronics, starting from number systems, Boolean laws, arithmetic operations on binary numbers, ones complement and two's complement, and Boolean laws and logic gates. Okay, universal gates, different types of logic gates, and also realization of logic gates with the help of realization of the expressions of with the help of logic gates, and what else we have seen in the first chapter, and also mm, De Morgan laws, which are very much important in realization or simplification or minimization of a given Boolean expression. After that, we have seen the standard canonical forms, that is sum of products form and product of sums form. Sum of products are implemented or realized with the help of AND or NAND and AND realization. Similarly, product of sums form can be realized with the help of OR AND realization or NOR realization. And after that, we have seen what is known as K maps, Karnaugh maps, 2 variable, 3 variable and 4 variable Karnaugh maps. Grouping of Karnaugh map cells into different kinds, that pairing pairs, quads and octets, so that the you can able to simplify the given Boolean expression and realize with the less number of logic gates after realization. So these are all the things we have discussed in the first chapter, that is basics of digital electronics. Now we will move on to the second chapter, that is logic families. So in this lecture, we will mainly concentrate on the classification of logic families, comparison of all the logic families, and so on. Okay, so the main objective of this lecture is to know different types of logic families like TTL, CMOS, and ECL logic families. TTL stands for transistor logic. CMOS stands for complementary metal oxide semiconductor logic, and ECL stands for emitter coupled logic. So these are the different types of logic families that are available in addition to the other logic families. And uh, in addition to that, we'll also know the types of different specifications that you need to know for each and every logic family. So there are the predefined terms for any logic family, that is specifications, how to judge whether this logic family is correct for my application. So depending on application, you can choose any one of the logic family based on its specifications. Okay, so we will see what are all the specifications available for any logic family, and also comparing all the logic families like TTL, CMOS, and ECL logic family comparison. So based on application, which logic family I need to use, all those things we will be discussing in this lecture. So we will now see the first classification of logic families. So basically, logic families are classified into two types. First one is bipolar logic family, and the second one is unipolar logic family. So basically, logic families are classified into mainly two types. One is bipolar logic family, and second one is unipolar logic family. What do you mean by this bipolar? So the current conduction in this logic family is due to both the electrons as well as holes, whereas in unipolar logic family the current conduction is due to only either holes or electrons. That is the meaning of unipolar means single, and bipolar means two. Okay, so that's why the current carrying will be due to only either electrons or holes in unipolar, and it is due to both electrons as well as holes in the case of bipolar logic family. So that's why BJTs, bipolar junction transistors, are called will be coming into the category of bipolar, and MOSFETs will be coming into the category of unipolar. Okay, so again, these bipolar logic families are classified into two types again: saturated and non-saturated. So what do you mean by this saturated and non-saturated? In the case of saturated, the transistors will be operating in the two regions, that is cutoff region and saturation region. And in the case of non-saturated, the transistor will not get saturated. That means the transistors will not go into saturation region. Instead, it will remain in like active region. So cutoff and active regions will be the region of operation of transistor in the case of non-saturated logic family. Whereas in the case of saturated logic family, the transistor will be in cutoff and saturation regions. Whereas in non-saturated, the transistor will not be in saturation. Instead, it will be in active region only. So in addition to cutoff, the other region of operation of transistor will be active. That is the meaning of non-saturated and saturated logic family. Again, there are different types in saturated logic family. They are resistor transistor logic, direct coupled logic DCTL, and integrated injection logic and I square L, diode transistor logic DTL, high threshold transistor logic HTL, and the one of the important logic family which we will be discussing further is transistor logic. In short form, you can call it as TTL. So this is very important logic family which you need to understand in the case of saturated bipolar logic family. So this is in our syllabus, transistor logic. Again, in the transistor logic, you are having different types like standard TTL, high power TTL, low power short key. Depending on application, you can use any one of the TTL logic family. If you want low power IC, you need to use low power TTL IC, and if you want to use faster, so that you can use short key TTL, like that. Depending on the application, you can use any one of the different types of TTLs. And in the case of non-saturated, you are having two types. One is Schottky TTL and other one is emitter coupled logic. So this emitter coupled logic is the important one. And if you observe, emitter coupled logic family is the fastest logic family among all the given logic families. So that is the importance of emitter coupled logic. Next, coming to the unipolar logic family, we'll be having three types again in that unipolar logic family. First one is PMOS, NMOS, and CMOS. Okay, so these are the three logic families available in the case of unipolar, and in the case of bipolar there are many: RTL, DCTL, I square L, DTL, HTL, and TTL. So in our syllabus, we'll be mainly concentrating on this transistor logic and CMOS logic. So we are having these two logic families in our syllabus. That means we need to know something about these TTL, transistor logic family, and CMOS logic family. So these two are in our syllabus. So this is overall the classification of the digital logic family. Classification of the digital logic family. So mainly logic families are classified into two types: bipolar logic family and unipolar logic family. Again, bipolar is divided into two: saturated and non-saturated. In saturated, there are different types of logic families like resistor transistor logic, direct coupled logic, and direct coupled transistor logic, integrated injection logic, diode transistor logic, high threshold transistor logic, and transistor logic. These are all the different types of logic families available in saturated type of bipolar logic family. And in the case of non-saturated, you will be having Schottky TTL and emitter coupled logic. And in the case of unipolar logic family, you will be having three types, that is PMOS logic family, NMOS logic family, and CMOS logic family. So these are the different the classification of different logic families. Okay, next we will see logic families. A miniature circuit on the surface of semiconductor material is called a chip, and the chip you can call it also as a integrated circuit. So what is an IC? Integrated circuit. Integrated circuit is a miniatured circuit on the surface of semiconductor material. You can call that as a integrated circuit, so which will be available in the form of IC. The full form of IC is nothing but integrated circuit. IC is defined as it is a miniatured circuit on the surface of semiconductor material. So whatever the electronic devices you are using, like resistors, capacitors, inductors, transistors, diodes, all those things will be mounted on the surface of semiconductor material like silicon or germanium or gallium arsenide. All these are the examples for semiconducting materials. So upon those semiconducting materials, we are mounting all these devices like resistors, capacitors, inductors, diodes, transistors. All those things will be incorporating together to form a digital circuit. So that miniature digital circuit, you are calling it as IC. That is nothing but integrated circuit. Next, the techniques for manufacturing ICs are bipolar and metal oxide semiconductor. So logic families are nothing but the techniques for manufacturing the integrated circuits. Logic families are nothing but the techniques for manufacturing the integrated circuits, and those are happen to be bipolar and unipolar logic families. And in the case of bipolar logic families, you are having different types. In the case of bipolar logic families, you are having different types: diode transistor logic, for example, diode transistor logic, transistor logic, and ECL. Okay, so these are all the different logic families available in bipolar. And in the case of MOS families, you will be having P channel MOSFETs, N channel MOSFETs, and complementary MOSFETs, CMOS. PMOS, NMOS, and CMOS are the three types available in MOS families. So all these logic families are nothing but the techniques used for manufacturing the ICs. Remember this. Okay. In the case of MOS families, you'll be having P channel, N channel, and complementary MOSFETs. So bipolar, in general, bipolar logic families are faster compared to the MOS families, and these bipolar logic families are mainly used for the manufacturing of small scale integrated circuits and medium scale integrated circuits. The full form of SSI means small scale integrated circuits and medium scale integrated circuits. So for the manufacturing of SSI and MSI ICs, small scale and medium scale integrated circuits, we will be using this bipolar logic families. Either any one of the bipolar logic families like diode transistor logic, transistor logic, emitter coupled logic. All those logic families are used for the manufacturing of small scale integrated circuits and medium scale integrated circuits, and these are very much faster compared to the MOS families. And after that, the MOS logic family is mainly used for the uh, manufacturing of large scale integrated circuits. LSI stands for large scale integrated circuits. So MOS logic families are mainly used for manufacturing the large scale integrated circuits. So if you want to produce the IC in large number of in large scales, then you need to go for MOS logic family. For small scale and medium scale, you will be going for bipolar technology or bipolar logic family. So a digital family is a group of compatible devices. A digital family is a group of compatible devices with same logic levels and supply voltages. A digital family or a logic family is a group of compatible devices with same logic levels and supply voltages. So for example, if you are considering a simple OR gate or AND gate or even NAND nor universal logic gates, for the manufacturing of that special, if you consider an example, for an example, if you are considering NAND gate manufacturing, I will be manufacturing the NAND gate with the help of any type of logic family, like diode transistor logic family I can use, transistor logic I can use, emitter coupled logic I can use, P channel PMOS I can use, NMOS I can use, CMOS I can use. By using any one of the logic family, I can able to manufacture what you can call an example of NAND gate. Okay, so if you are manufacturing a particular gate like NAND gate by using different logic families, so each and every NAND gate which are manufactured with the help of different logic families will be having its own logic levels and supply voltages. Its own logic levels and supply voltages. If you consider a TTL NAND gate, it will be having different logic levels. That means logic 0 will be defined with some voltage, low voltage, and logic 1 will be defined with some high voltage. And also it has some fixed supply voltage. That means each and every digital logic family will be having same logic levels and supply voltages. Okay, so logic levels and supply voltages are specific to the logic family. These logic levels and supply voltages varies from one logic family to other logic family. Okay, next we will see TTL devices. Transistor logic is a widely used family, as I said earlier. So these transistor logic families are mainly used for what you can call the manufacturing of small scale integrated circuits and medium scale integrated circuits. So TTL is fast, these are not expensive that much and easy to use. And bipolar transistor technology is used for MSI and SSI, as we have discussed earlier. And these TTL devices are mainly used to build all kinds of digital circuits and systems. Okay, so TTL devices are mainly used to build all kinds of digital circuits and systems. Coming to the CMOS devices, CMOS stands for complementary metal oxide semiconductor devices. CMOS stands for complementary metal oxide semiconductor devices. So they combine P channel and N channel MOSFETs. As you know, there are three different types of MOS logic families. One is PMOS, and the second one is NMOS, and the third one is CMOS, which is nothing but the combination of PMOS and NMOS. Okay, so this is how CMOS is defined. CMOS is nothing but combination of one PMOS and NMOS will give you a CMOS logic family. Okay, so CMOS devices mainly combines PMOS and P channel and N channel MOSFETs. So they are in push-pull arrangements. So if the output is pulled 0, that means it is not connected to VCC. If the output is pulled to VCC, it is not pushed to ground. Likewise, so CMOS devices are connected in push-pull arrangement. So depending upon the input variations, either the output is connected to VCC or ground. Okay, so output is pushed or pushed to VCC and pulled to ground. Next, CMOS devices have very low power, so that is the main advantage of using CMOS logic families. So among all the logic families, among all the different logic families, CMOS logic families will be having less power dissipation. CMOS logic families will be having less power dissipation. That is the main advantage of using CMOS logic families. Next, they are used in pocket calculators and watches. These are the examples of where we are using CMOS logic family. Next, coming to the ECL logic families. ECL devices, the emitter coupled logic is the fastest of all the logic families. As I have said earlier in the earlier slides, this emitter coupled logic family is the fastest logic family among all the logic families. ECL is realized using differential amplifier. ECL is because since why the ECL logic family is the fastest, because it uses the differential amplifier. It is realized using differential amplifier, hence they are not driven into saturation. So that's why ECL logic family will be coming into the category of non-saturated bipolar logic family. ECL logic family will be coming into the category of non-saturated bipolar logic family, because whatever the active devices you are using in the ECL logic family, like transistors, all the transistors are not driven into saturation. That's why ECL logic family is a non-saturated logic family. So ECL devices are used in applications where very high speed is essential. So there will be some applications of digital circuits in which all the digital circuits must be operated in a very faster manner. So if you want to have the digital circuits which will be operated in very faster manner, you need to manufacture those digital circuits with the help of ECL logic family, so that all the devices, all the digital circuits which are digital ICs which are manufactured with the help of ECL logic family will be faster. So they mainly ECL logic families are used in applications where very high speed is essential. So employed emitter followers at output stage and hence high degree of fan out. We will see what is this fan out and all the specifications of logic family. So the main disadvantage of the ECL logic family is it requires it has highest power dissipation per gate. So if you are manufacturing a gate with the help of ECL logic family, it has highest power dissipation compared to other logic family. That is the main disadvantage of ECL logic family. And the main advantage of ECL logic family is it is fastest logic family. So depending on application, you can use this ECL logic family. So if your application needs fastest digital ICs, then you need to go for the digital ICs manufactured with the help of ECL logic family. Okay, so depending on application, you can use any one of the logic family. Next, we'll move on to the next topic, that is specifications of digital IC logic families. So specifications of a logic family, that means, so there are some predefined parameters from which you can able to differentiate different types of logic families. Like there should be some specifications for defining a logic family. So first specification is the propagation delay time. So propagation delay time is defined as the time taken for the output of a gate to change after the inputs have changed. Okay, so that means if you are giving, for example, let us say I am considering a simple AND gate, two input AND gate I am considering. Okay, I am giving two inputs A and B, and I am getting the output Y. I'm getting the output Y. So let us say time t is equal to 0. I am applying the inputs. It after what time you are getting the output changed? At what time you are getting the output changed is nothing but the propagation delay. Okay, so since the gate, what do you mean by this AND gate? It is again the manufactured with the help of any logic family, like TTL, CMOS, ECL, any one of the logic family is used for manufacturing of AND gate. So if you are using any logic family, that means indirectly you are using inside what? Resistors, diodes, transistors, PMOS, NMOS, CMOS, any of the electronic devices you are using, which are mainly what time consuming for transferring the input signal from one device to the another device. So during the transition of the input signal from input to the output, it will be taking some time. That is nothing but propagation delay. So if is there any change, if it is there any change in the input, after how much time you are getting the change in the output, that you are defining it as propagation delay. It is the time taken for the output of a gate to change after the inputs have changed. Okay, so at time t is equal to 0, if you are changing the inputs, after propagation delay time, TPD, after propagation delay you will be getting the some change in the output, and that delay you are calling it as propagation delay time of any logic family, or propagation delay time of any logic gate for that matter. Okay, so this is the overall definition of propagation delay. It is the time taken for the output of the gate to change after the inputs have changed, after the application of inputs. Next specification we will discuss, power dissipation. Power dissipation is the amount of power dissipated in an integrated circuit. So power dissipation is nothing but the amount of power dissipated in an integrated circuit. So typically again if you are considering any AND gate or OR gate which is manufactured with the help of any logic family, any logic family will be having some supply voltage. Any logic family will be having some supply voltage and also current flowing, and multiplication of these two will give you the power. Multiplication of these two will give you the power. Power is nothing but voltage multiplied by current flowing through that circuit. Okay, so power dissipation is nothing but multiplication of the supply voltage with the current flowing through that circuit. Okay, so power dissipation is the amount of power dissipated in that particular IC due to the application of VCC and due to the flow of current in that particular circuit. Okay, so if you observe, the for CMOS logic family, this power dissipation is very low. That is the advantage of CMOS. Next we will see the fan in. Okay, so as the name itself tells, it is the maximum number of inputs that can be connected to a gate. Fan in is nothing but it is the maximum number of inputs that can be connected to the input of a gate. That is the meaning of fan in. Similarly, the opposite one, that is fan out, it is the maximum number of outputs that can be connected to a gate. Fan out is nothing but the maximum number of outputs that can be connected to a gate. This fan in and fan out mainly depends upon the current carrying capability of the internal devices used in that particular logic family. So fan in and fan out mainly depends upon the current carrying capability of the internal devices used in the particular circuit, in the particular logic family. Okay, so next one, noise margin. Noise margin is nothing but it is the circuit's ability to tolerate, okay, to tolerate or to withstand noise signals in is noise immunity, and it is a measure of this noise margin. Okay, measure of this noise immunity is nothing but the noise margin. Okay, so noise margin is nothing but the circuit's ability to tolerate noise signals is noise immunity, and a measure of this is called noise margin. So for example, if you are considering a simple logic family in which you are giving the input voltage logic levels, okay, there are some logic levels for fixed predefined logic levels for logic 0 and logic 1 in a particular logic family. That means logic levels, you are defining a range. So in that range, if you are giving some voltages in that range, and all those voltage ranges can be treated as logic 0 by that particular logic family. Similarly, a voltage range is defined for logic 1 voltage level, logic 1 level. So that means in that level, whatever the voltages you are giving to that particular logic family, all those voltage levels will be treated as logic 1 by that particular logic family. That means there is some margin of voltage levels. So if you are applying that margin of voltage levels to that logic family, it will be treated as either logic 0 or logic 1 depending upon the logic levels of that particular logic family, and that you are calling it as noise margin, that you are calling it as noise margin. So all these definitions like propagation delay time, power dissipation, fan in, fan out, and noise margin, so all these are nothing but the specifications of any logic family, specifications of any logic family. So if you are manufacturing a logic gate with the help of any type of logic family, we should see all these specifications. Okay, so for this AND gate, what is the propagation delay time, what is the power dissipation, what is fan in, what is fan out, and what is noise margin, all those things will be taken into consideration for selecting a logic gate in using some digital circuit applications. Okay, so based on all these specifications, depending on the use of the depending on the application you are using, you can select all the digital ICs which are used in manufacturing the any digital circuit. Okay, so these are all the important specifications which are defined for any digital IC which are manufactured using different types of logic family. So for any logic family, you can define all these specifications. What is propagation delay time, what is power dissipation, how much is fan in, how much is fan out, how much is the noise margin for that logic gate, all those things. Okay, these are very important in judging the logic gates, in choosing the logic gates for designing any digital circuit. Next we will see comparison of different logic families. We have we will see the comparison of the three logic families TTL, three logic families TTL, ECL, and CMOS, and the specifications of any logic family are happen to be noise margin, fan out, fan in, propagation delay, and power dissipation. So if you observe for TTL, ECL and CMOS, if you observe the noise margin, okay, so noise margin is zero point 0.5 for TTL, 0.16 for ECL, and 1.5 for CMOS. So the main advantage of CMOS logic family is its noise margin is high. Okay, for example, what do you mean by this noise margin 1.5? For example, if CMOS is using the supply voltage starting from 0 to 5 volts, starting from 0 to 5 volts, so that means VCC is nothing but 5 volts for CMOS logic family. So if noise margin is 1.5, that means, so for 0 to 5 volts I am assuming 0 as logic 0, and I am assuming 5 volts, I am assuming 5 volts as logic 1. This is basic of understanding or defining the logic levels for a particular logic family. So 0 volts is assumed as logic 0 and 5 volts is assumed as logic 1. What do you mean by this noise margin? Instead of giving 0 as 0 volts as input to this any gate, if if it varies from 0 to 1.5 as well, that means if the input voltage level is from 0 to 1.5, that logic family will be treated as logic 0 only. So even if you are applying this voltage ranges 0 to 1.5, the logic family will be understanding that all those voltage levels within this range will be as logic 0 only. Similarly, for logic 1, if you are considering 3.5 to 5 volts, this voltage range, if you are applying the voltage range between 3.5 to 5 volts, that all the voltages, uh, um all the voltages which you are applying within this range will be treated as logic 1 by that particular logic family. So that is the meaning of noise margin of 1.5. Okay, so that is the main advantage of CMOS logic family. CMOS logic family will be having high noise margin, that is 1.5, around 1.5. So if you observe fan out for three logic families, all these are almost all same. That means, what do you mean by fan out? The maximum number of outputs that can be connected to a particular gate, so it is greater than 10 for all the logic families. And fan in is nothing but the maximum number of inputs that can be connected to a logic gate, that is fan in is more for TTL logic family, 12 to 14, and ECL it is greater than 10, CMOS it is greater than 10. And if you observe propagation delay for the different logic families, it will be very less for ECL. It is almost all less than 3 nanoseconds. It is almost all less than 3 nanoseconds. So that's why ECL, since propagation delay of ECL logic family is very less than 3 nanoseconds, that's why ECL is the fastest logic family among all the logic families. ECL is the fastest logic family among all the logic families. Similarly, if you observe the power dissipation for the three logic families TTL, ECL and CMOS, power dissipation will be very less for CMOS logic family. This is in the orders of 0.001 milliwatts. It is in the orders of milliwatts, that is 0.001 milliwatts. If you compare the power dissipation of CMOS with the ECL and TTL, for ECL it will be 175 milliwatts and for TTL it will be 10 milliwatts, which is very greater, which is very much higher compared to the power dissipation of CMOS logic family. So for CMOS logic family, the power dissipation will be 0.001 milliwatts, which is very less compared to the other two logic families TTL and ECL. That's why CMOS logic family will be having less power dissipation. That is the main advantage of CMOS. And the advantage of ECL is it is the fastest logic family because it is having less propagation delay compared to the other two. Okay, so these are the comparison of the three logic families TTL, ECL and CMOS, comparing all the specifications of any logic family like noise margin, fan out, fan in, propagation delay in nanoseconds, power dissipation in milliwatts. So this is the overall comparison of the different logic families. So depending on application, you can use any one of the logic family. So if in your application, if you want to use the digital IC having less propagation delay, it should act faster for a given input, you need to use ECL logic family. So if your application needs speed, then you can go for ECL. If your application needs less power dissipation, you can go for CMOS. Likewise, depending on application, you can use any one of the logic family ICs. Next you can have the some numbers, IC numbers, integrated circuit logical IC numbers, CMOS logical IC numbers, quad 2 input gates. Okay, so 4001 is a quad 2 input NOR. What do you mean by this quad? Quad is nothing but how many number of NOR gates are available? 4. Quad stands for 4, dual stands for 2. Likewise, so 4001 is the quad 2 input NOR gates. That means how many number of NOR gates are available? 4 number of NOR gates are available, and each NOR gate will be having how many inputs? 2 input. Okay, that is the meaning of this quad 2 input NOR, quad 2 input NAND, quad 2 input XOR, quad 2 input XOR, quad 2 input OR. All those things are the different types of logic gates, CMOS logic ICs. Okay, so overall summary, we have discussed we have discussed in this lecture about the TTL, CMOS and ECL logic families, and the specifications of logic families like propagation delay time, power dissipation, fan in, fan out, and noise margin, and also comparison of the above three logic families, TTL, CMOS and ECL logic families, and based on the comparison of logic families, depending on application, you can use any of the logic gates depending on application. So, and also we have seen some of the digital IC numbers, CMOS IC numbers. Next we will move on to the quiz. Any digital family is a group of compatible devices with same logic levels and which option is correct, and supply voltages will be the correct answer. So any particular logic family is a group of compatible devices with the same logic levels and supply voltages. So these logic levels and supply voltages are only specific to the logic family. That means logic levels and supply voltages varies from one logic family to other logic family. So logic levels and supply voltages are specific to the logic family, and these logic levels and supply voltages will be varying from one logic family to another logic family. So option A is correct. Next, which logic family is the fastest logic family? As you know already, so ECL is the fastest logic family, which is happen to be non-saturated bipolar logic family. ECL is the fastest logic family. That's why ECL will be having less propagation delay time. Next, a logic family is fastest because it operates in A, cutoff and active region. Okay, so ECL logic family will be operating in cutoff and active region. It is not moved into saturation region. That's why ECL logic family is called non-saturated. Okay, it is not the transistor is not going into a saturation region. The transistor remains in active region itself, cutoff and active region only. So a logic family is fastest because it operates in cutoff and active region. Here the answer he has given is wrong. The correct answer is cutoff and active region. Okay, so example for fastest logic family is ECL logic family, which is happen to be non-saturated logic family. Non-saturated means in those non-saturated, all the transistors will not be entering into saturation region. That you have to remember. So the fastest because it operates in cutoff and active regions. Next, frequently asked questions. Write about the specifications of logic families and compare logic families. Next, list any for digital IC numbers. So that completes the session. Thank you for listening.